What is going on YouTube? It's the Middle School Math Man. This video is on direct variation. So by definition, a direct variation is a specific relationship in which there is a constant ratio between all ordered pairs. Again, it's a specific relationship in which there is a constant ratio between all ordered pairs. And for direct variation, that ratio is going to be represented as y over x. So when we take all these ordered pairs and we take the y value and divide it by the x value, there should be a constant relationship. Direct variation equations, they are written in the form y equals kx. Now that equation might look similar to something else we've recently talked about. That is very similar to slope-intercept form, except we don't have that b. So we're going to talk a little bit more about that here in a bit. So the first type of problem I could ask you is I could give you a bunch of points like I have in 1 through 4, and I could ask you, what is the constant? And then once you know that constant, the constant is going to be k. So in our equation, y equals kx, the constant is going to be k. That's going to be this thing that stays the same. That is the constant ratio that's the same between all the points. So in number 1, we're going to do y over x. So we have 3 divided by negative 15. We have 1 divided by negative 5. We have negative 2 divided by 10. Now anytime there's a 0, you can just kind of ignore it. That doesn't really play into our k because, you know, anything with 0 is going to be 0. So let's look here. 3 divided by negative 15. If we reduce that, we are going to get negative 1/5. 1 divided by negative 5 is also negative 1/5. Negative 2 divided by 10 is also negative 1/5. So my constant is negative 1 over 5. Again, constant is k. So in this equation, y equals kx, we would just have y equals negative 1 over 5x. That would be my equation. So let's go on to number 2. Again, y over x, so we have negative 12 divided by negative 6. We have negative 2 divided by negative 1. 4 divided by 2. 8 divided by 4. When you simplify those things, they should all be the same. That's my constant. So if you simplified all of those, my constant is going to be 2. So my equation should be y equals 2x. Now at this point, if you wanted to pause the video to try 3 and 4, that would be a good idea. So in number 3, again, negative 16 divided by negative 12. Negative 8 divided by negative 6. 4 divided by 3. If you were to simplify all of those, your constant is just going to be 4 over 3. Positive 4 over 3. So my equation is y equals 4 over 3x. Last one, we have 7 divided by negative 7, 4 divided by negative 4, negative 2 divided by 2. So if you simplified all of those, your constant is going to be negative 1. So now your equation, you can just write y equals negative x. The second type of thing I could ask you, identify, or in this case I'm going to circle the equations that represent a direct variation. So if we look at number 5, y equals kx. That does represent a direct variation. Number 6, y equals kx. That is not in direct variation form because we have this plus 1 out there. So like I mentioned earlier, you can think about direct variation kind of as slope-intercept, without the y-intercept. Now there is a little bit of an issue with 7 and 8. We need it in y equals form so we can see if it's direct variation. So for number 7, we need to divide, so it's going to be y equals 3x. That is a direct variation. And then for number 8, let's see, I'm just getting y by itself. So y is going to equal, we can probably already tell that it's not going to be a direct variation because we're going to have that y-intercept, we're going to have that 5. So we have two problems that are, representative of a direct variation. So it says, if yes, identify the constant. So in this case, number 5, the constant is just the thing in the k spot in the y equals kx. So the number next to the x. In that case, it's negative 2 over 5. For number 7, k is going to equal 3. Now, taking that idea where we don't have a y-intercept, y equals kx, let's look at 9, 10, and 11. So here I give you graphs. First, identify the graphs that represent a direct variation. So if it's y equals kx, that means the y-intercept has to equal 0. Number 6 and number 8 up here, I'm gonna erase those because we don't want those circled, but number 6 and number 8, we had a y-intercept, so that means it wasn't in direct variation form. So if we look at number 9, the y-intercept is 0, so that should be a direct variation. Number 11, the y-intercept is 0, that should be a direct variation. Number 10, we have a y-intercept of negative 3. So because we have a y-intercept of something other than 0, that is not going to be a direct variation. So in number 9, direct variation, so we're trying to find that constant. Another word for constant could be slope. Whenever I gave you a line and you found the slope, that slope was the same between all the points on that line. That slope was constant throughout the whole entire line. So if we look at number 9, essentially all we're doing is we're finding the slope of the lines. So let's see, we're rising 1, 2, 3, 4, and we're running to the left 1, 2, 3, 4, 5. So we ran to the left. That line has a negative slope. So k is negative 4 over 5. Number 11, we have a positive slope. We're rising 3 and running 1. So my k is 3 over 1, which is just 3. All right, we're going to move on to the last type of question I could ask you. So, in these problems, this is kind of similar to what we did on the very first slide here where I gave you a bunch of points. But you probably notice we are missing a value. So, in number 12, for example, I need to figure out if this set of ordered pairs represents a direct variation, what must x be? So we're trying to find a missing value. We're going to set up a proportion. So my proportion, when we were trying to find k, we did y over x. So when I set up this proportion, I'm going to do y over x equals y over x. So in this case with number 12, I'm going to have 14 over 5 equals 28 over x. So with proportions, again, we need to cross multiply. So I know some of you have learned the little butterfly method, it's called. That's just cross multiplication. So 14 times x is 14x. 28 times 5 is going to be 140. So if we're solving for x, we need to divide both sides by 14. And then you should get your answer which is going to be 10. So if you were to check this problem, you would plug in 10 for x. So let's do that. So if we plugged in 10 for x, I'm going to do it down here under number 14, and then I'll erase it. So we're going to have 14 over 5, and then we're going to have 28 over 10. 14 over 5, you can't reduce. 28 over 10, however, we can reduce to 14 over 5. So k, when we found k, we did y over x, we got that it's the same, so it's constant. So that means we are correct. That missing value is in fact 10. Let's go down to number 15. We're missing an x, or excuse me, we already did one where it's missing an x. Let's do number 14. We're missing a y. So again, y over x equals y over x. So in the first ordered pair, I'm going to have y over negative 3 equals 12 over negative 18. So when I cross multiply, I'm going to get negative 18y equals negative 36. So I'm going to get y equals positive 2. Again, for checking purposes, I'm thinking that y is 2, so I'm going to have 2 divided by negative 3. Then my other ordered pair, I'm going to have 12 divided by negative 18. And if I were to reduce 12 divided by negative 18, I would get 2 over negative 3. So that change, that k, is constant. So we are correct. Last problem, number 16, is just like 12 through 15. We're just kind of representing that ordered pair in a different way. So the comma kind of separates the two ordered pairs. So we're wondering, or we're trying to find y when x is 14. So if you want to actually write this as an ordered pair, you can do that. That's a y. So x is 14 and y we're trying to find. So that's my first ordered pair. My second ordered pair, if y equals negative 3 when x equals 6. So x is 6, y is negative 3. So now we're just going to go ahead and do the same thing. Y over 14 equals negative 3 over 6. Cross multiply to get 6y equals negative 42. And then we're going to get y equals negative 7. So that was our video on direct variation. Again, just remember, the equation, the form that direct variation is in is y equals kx. So essentially it is slope-intercept without the y-intercept. K is our constant. That's what k stands for. So when we were trying to find my constant, or my k, we did y over x. And that y over x, that ratio needs to be the same in between every single point. Otherwise, it is not a direct variation.